Hey guys, what's up? This is AJ of Pushing Code, and for this episode, we're going to be talking about event sourcing and CQRS design patterns and how we can implement them in Java using Spring Boot and Axon framework. So let's first talk about event sourcing. The idea behind event sourcing is that every change in state that transpires within the application must be captured and persisted. So let's take, for example, the process of bank accounts. A new client heads over to a bank and opens up a new account. The bank creates the account and activates it so that it's in a usable state. The client then decides to deposit a certain amount to his account. Now, these are all considered events, and for every event that occurs, the state of the account aggregate is changed, and normally this is good enough for us. But in event sourcing, we store every bit of these state changes, and when the account was created, when it was activated, when the client deposits to his account, and so on, as events in the event store. The event store is a database platform of your choosing, and it could be an RDBMS or NoSQL, where we persist these events. These events are appended in the event store with a unique global identifier and an aggregate ID to determine which instance of an aggregate a certain event belongs to. Now, why would we want to use or implement event sourcing? In event sourcing, the state of an entity is persisted as an event in an event store. Whenever the state of a business entity is changed, say for example, an account has been deactivated from an activated state, or an order has been fulfilled causing its status to be updated, these events are appended into the event store. Whenever you save an event, that is a single operation, and it is considered to be inherently atomic. Related to this advantage, since we are saving every state change of an aggregate in an event store, this also practically gives us reliable and accurate audit logging for free. If you need to review or backtrack events that have transpired on an aggregate or entity, say for example, troubleshooting, security, or compliance purposes, you can just refer to the event store where you persist these state changes. Last but not the least, one advantage of implementing event sourcing is that you have the power to reconstruct an aggregate into its previous state with the help of your event store. Your event store is essentially a history of all events or state changes that an aggregate went through. And in the event of a production issue, say an error that caused an object to be in an undesirable, faulty state, you can just backtrack to its state at a certain point in time prior to the occurrence of that error to investigate what caused the issue. It may be restored to that state to be the current state of the object if necessary. Now let's go to CQRS. CQRS stands for Command Query Responsibility Segregation. And the idea behind this is that reads and writes are separated into different models, using commands to update data and queries to read data. In CQRS, the command side's responsibility is to handle all incoming commands like requests, say from an HTTP REST API, apply the appropriate event for that command, persist that event into the event store, and publish it over to the query side, who will then handle that event, presumably containing the latest state of an aggregate, and use that state to update the view stored in the query store, which is again a separate database. The query store basically just saves the latest state of an object, in contrast to an event store, which persists a log of state changes as events. Besides this, it is also the responsibility of the query side to present the most up-to-date view to a front-end application like a website or another REST API. Now, let's talk about the pros of implementing CQRS with event sourcing. The first advantage would be that it's relatively easier to aggregate data across multiple microservices throughout your application. Let's say you have an existing system implemented in a microservice or even a database for service pattern where each of the microservices are responsible for their own data. And if we say you have an account service to give you specific details for a certain bank account, and the transaction service that gives transactions done with this bank account, what you would normally do is access these services individually and have an application to aggregate the data from these services into a single view. I'm not saying this is all bad, but at a later time, you may come to realize that this is causing some tight coupling between your aggregating service and the microservices involved, and you don't want this. With CQRS, you have a query side that keeps the latest state or changes of an aggregate based on the events it receives from the command side and persists these state changes into its own query store as a query-specific view. So going back to our scenario earlier, when you query for account details with its transactions, there is no need for an aggregating app to collect the data responses from the account and transaction services. Instead, this information can be presented from the query side with the queried or requested data obtained from the query store. Another advantage of CQRS with event sourcing is that command side and the query side can be scaled independently of each other. Let's say you are observing or expecting more reads operation than writes. Then you can scale up your query side, who is responsible for delivering query-specific views independently of your command side. Or it could even be vice versa, depending on the expected load of your system. You are also free to choose the kind of database solution you need for your query store and event store. If you need your query store to be NoSQL and you want your event store to be RDBMS like MySQL or Oracle database, you're free to do so because their responsibilities are separated anyway. Of course, as the name CQRS already implies, command's responsibility and query's responsibility are completely separated, segregated, and independent of each other. They could also have their own resources, allowing you to scale or change something without affecting the other side. You could basically do or change almost anything from validations, protocols, or how they interact with external systems from either command side or query side with very minimal effect or without affecting the other side at all. When either the command or query side goes down, it doesn't necessarily have to affect the other. And lastly, CQRS with event sourcing is normally ideal for cases when you need a separate model for reads and writes or updates. Now on to the disadvantages of CQRS with event sourcing. This may increase the complexity of your system, given that you basically have two subsystems that have different responsibilities to maintain and build on. Potential code duplication. You may or you may not be aware that the code you're writing is identical from what's already written from the other side of your CQRS system. So what you could do is to write a core library containing commonly used POJOs and helper classes that could be used as a dependency from both command and query side. Lastly, CQRS may be eventually consistent given that writing or updating takes place in the command side. The state change will have to be published as an event over to the query side through an event bus, which is a pub/sub messaging platform like, say, Apache Kafka or RabbitMQ. That event may take some time to propagate over to the query side depending on how your event bus performs or how it was configured. So when you query for a certain view or make a request from your front-end app, the changes you expect may not be instantaneous. There could be a tiny bit of lag, but usually that delay is negligible. Before we proceed with building our demo, I just want to share with you some useful terminologies which you're probably going to hear a lot when talking about CQRS with event sourcing. Like a command, which describes an intent to change an object state. Usually, in an actual application, you're going to have maybe a web app or a mobile app that calls in a REST API for when you're going to add or update or save something, and this request serves as a command. A query describes an intent to request for information for an object state. Again, from our example, from a web app, you're going to search for something like maybe get information for a certain account. These are considered as requests to query. Events describe something that has occurred in the application. An event bus is a mechanism that distributes events to any application that wants it or responsible for handling these events. The command side of CQRS produces the events. It publishes these events over to the event bus, and the event bus dispatches these events to the query side of your system. This could be any pub/sub messaging platforms like Kafka or RabbitMQ, or if you're using Axon framework like what we're going to use for this demo, the Axon server. Now, the event store is where things get interesting. Normally, when talking about CQRS and event sourcing, we don't just refer to the event bus alone, because this is not the only thing we need. Instead, we constantly refer to the event store, which is basically just an event bus with persistence. An event bus not only dispatches events over to the query side, it also saves them with an aggregate ID so that it could also be retrieved at a later time when needed. So what we will build today is just a very simple demo of CQRS with event sourcing. Something that is not complex and implemented on a small scale so that it can easily be presented to you guys. This demo will be about bank accounts, where it will be able to create an account and debit and withdraw from that account, and these will all be under the command side. It will also be able to give the account's details like its balance and status, and this will fall under the query side. We're going to build a Spring Boot app which will have two major packages, a package for the command side and a package for the query side. From the command side, we will open up a RESTful endpoint to submit requests to create an account, to deposit to an account, and to withdraw from an account. These requests will be processed as commands and produce the respective events and allow the event store to persist these events in an in-memory storage, which is H2DB, and dispatch them over to the query side. Since we will not be using Axon server as the event store to make things simpler, the implementation that Spring Boot will auto-configure for us will be the embedded event store, which we will talk a little bit about later. Under the query package, it will contain the code to handle the events dispatched to us by the event store. For example, if an account-created event occurs, we will handle it by saving that account over to our in-memory database, which is again H2DB. We will also open up a RESTful endpoint here to submit a query request to fetch an account's details. Now, the framework that we will be using to do the heavy lifting of actually implementing CQRS with event sourcing is the Axon framework. If you're not familiar with this framework, don't worry, any intermediate or advanced knowledge is not required, and I will just be showing you the basics of working with this framework. Axon is an open source framework for implementing DDD or data-driven design and CQRS, and it is based in Java. It is developed by an enterprise platform development and provider company called Axon, and I'm not really advertising the use of this framework, but I'm not that much familiar with other alternatives either, and this is a pretty reputable framework in my opinion. A simple Google search would give you several forums and blog posts about it. It also has a good presence in Stack Overflow. Their documentation is pretty neat and straightforward, which I have pasted the link in the description below if you want to check it out. So I figured, why not use this to do most of the work of actually implementing CQRS and event sourcing? It does the heavy lifting for you, like storing and posting events in an event store. They've pretty much abstracted the crucial and complex parts of implementing CQRS so that you could just focus on getting your apps or services to work with a CQRS design pattern. Now, we have two options for using this framework with our app. We can either grab its own configuration dependencies with Maven, or we could just use it with the Spring Boot and use its auto configuration dependency, which is what we will be doing for this demo. Now, let's move on to our project code. I've went ahead and created some of the boilerplate code and some POJO classes that aren't really significant to CQRS to make things faster. Let's talk about our POM here and see the dependencies we have. Some of the dependencies here are optional, but you should have the Spring Boot Starter Data JPA dependency here because we will be using Spring Data JPA for our ORM persistence layer. We will also need the Spring Boot Starter Web dependency for our REST APIs for both the command side to submit our create and update requests, and the query side to submit our query requests to get account details. The database that we will be using for both the event store and the query store will just be an in-memory DB called H2. And this is just so our demo would be simpler to implement and demonstrate rather than having Axon Server or Kafka as an event store. Now, on to our most important dependency, which is the Axon Spring Boot Star, which basically just auto-configures the beans we need, like the correct event store. And you will notice that we excluded the Axon server connected because we will not be using the Axon server for our event store, as I've said earlier. And that includes persistence because we will be using H2 database to save our events. Remember, as mentioned earlier, an event store is an event bus that dispatches events and a database where we save the events. If you refer to Axon Framework's official docs, it says that Spring Boot will auto-configure the Axon Server event store by default as the event store implementation. But since we just excluded the Axon Server connector dependency because we will not be using Axon Server as the event store, the embedded event store implementation will be auto-configured for us instead, since we will be using HTTP as the event store, according to Axon's official documentation. And you can easily verify this using the getClass method on the AutoWired event store bean. Now, as I've mentioned earlier, you will see two main packages here, one for the command side and one for the query side. Under the command package, one very important class in this demo is the account aggregate, which will just hold the state of an account at a certain point in time. And you will see how important this is because we will be writing in here the code to handle different commands and events so that an instance of this aggregate gets saved in the event store as an event. We will also have the command package where we will place the command classes, and right here is the base command class which we will extend to write our command classes. Each command class will have an ID for Axon to identify which instance of the aggregate it is applied on. And under the controller package, this is the bank account controller class where we will open up RESTful endpoints to create, deposit to, and withdraw from an account. And I have also prepared some DTO classes here to serve as request bodies for the said endpoints. As you can see, I've annotated them with @lambda with longbox at data annotation, just so I don't have to write all those getter and setter methods. But the longbox dependency for this demo is completely optional, just so you know. Feel free to just pause this video and copy these classes if you want to, or you can just get them from GitHub, which I have pasted the link in the description below. This entire project will be on GitHub for your reference, but there's really nothing special about them. They're just Pojo classes, and you can come up with them yourself. Now we go to our query package, and you will see that I also have a controller here for our REST API that we can call to get account details. We have an account class here which serves as a JPA entity to refer to the latest state of an aggregate, and will be stored in the query store, which is also H2DB. We also have a DTO class here for the query request, and as you can see, it only asks for the account ID. I've also prepared a JPA repository for the account entity. And right here, I also have a common package here containing the events that we will be using throughout this application. And I found it ideal to have them in a separate package, because events are going to be handled either from the command side or the query side. I'm also trying to prevent code duplication, and I find it odd to access an event from either the command or query package, because that would imply that the event only belongs to them. So it only makes sense to have them in like a core package. Again, feel free to just pause this video and copy these classes, or you can refer to GitHub for the full code of this project, which I've pasted the link in the description below. These event classes are basically just Pojos, and you can come up with them yourself. To start off, let's open the account aggregate class, and let's annotate this with @aggregate to let Axon know that this is an aggregate component. I also just want to annotate this with longbox SLF4J for easier logging, but this is optional. Now we have three fields here: the account ID, balance, and status. I will annotate the account ID field with aggregate identifier, so we can uniquely identify an instance of account aggregate. You will also notice a no-args constructor here. I think Axon needs this to properly apply events on an account aggregate instance. If you don't have it, you will encounter an exception. Now, what we will do first is to write the code to handle the create account command. And as you can recall, this is the create account command class, which just contains the account ID and the starting balance. Every command we have extends the base command class, which just holds the ID or the account ID field. You can see that it's using generics, but that's optional. If you just want your IDs to be long or string, then that's fine. I just want mine to be a bit flexible. What we want to do here is to annotate this ID field with @target aggregate identifier to let Axon know that this field, the ID field, is the unique identifier of the account aggregate that the command targets. Going back to our account aggregate class, it's also going to be a constructor, since this is the point at which we initialize a new account aggregate. Log.info. Now, the way we will handle commands in this application is by applying the corresponding events on the account aggregate. When we receive a create account command, we need to apply an account created event. To do that, let's use the aggregate lifecycle.apply method and give a new instance of the event we intend to apply, which is the account created event. When you call the apply method, the event gets persisted into the event store, and the event store dispatches this event over to the query side for further handling, like actually saving the new account to the database. Next is we will annotate this constructor with @command_handler to let Axon know that this constructor is for handling create account commands, and execute this code when it receives a command to create an account. Since we applied an account created event on the aggregate whenever we handle a create account command, we also need to handle that event. And we do that by writing another method with the event we want to handle as a parameter. Let's set the current state of the aggregate by updating the instance fields. ID of this balance, and we set a status of created. Now, when you create a new bank account, it also needs to be activated to be in a usable state. Normally, the bank would require you to deposit some amount before it gets activated, or that you wait for a day before it gets activated. For our case, I just want to activate right off the bat as the account gets created. To do that, let's apply the account activated event, passing the account ID and a status of activated. Now, for this to work, we need to annotate this method with event sourcing handler to let Axon know that this method is a handler for an event generated by the account aggregate. From this method we just wrote, we applied an account activated event. So again, we need to handle this event by writing another method annotated with event sourcing handler. So let's do a little recap of what we just did here. For any create account command that our app receives, we write a command handler method to handle that command. We handle that command by applying an event on the aggregate called account created event. The account aggregate generates that event and we wrote a method to handle it. In this event, we updated the latest state of the aggregate and applied another event called account activated event to activate the newly created account. And then write another method to handle that event by just updating the status to activate it. This is going to be pretty much the same for all the other commands that we intend to handle, like the deposit money command and withdraw money command for depositing and withdrawing money from your account and their corresponding events. So let's write the rest of those handlers. Received, account credited event, command, get account, and handler. Account credited, occurred. Now, the question is, how do we receive commands? Where does it come from? we know that requests will be coming in from the REST API that we will open up later, but how would those requests translate into commands? For this, we will need to spin up those commands ourselves as we receive those HTTP requests using the command gateway. Now, we don't want this to be auto-wired directly from our REST controller. Instead, we're going to call it from the service layer. I'm going to annotate this class with @service to let Spring know that this is a service component. And this is where I will access the command gateway as a dependency. Now let's write a method that returns a completable feature. Create account and takes in a create account request. We will call command gateway send method to send in a create. Sorry, that is should be create account request. Let's call command gateway send method to send in a create account command with the account ID being a randomly generated string and the starting balance which we take from the request. The send method returns a completable feature. That means it won't have to wait for the command to fully execute. It just returns to us the account ID that we generated. Why does it return the account ID? I can't say for sure, but that is how Axon implemented it internally. And we will do the same for request to deposit to an account and request to withdraw from an account. Deposit request, deposit request. My command get amount withdraw request get amount. And from our controller, as you can see, the methods to accept different requests are already prepared. We have the post method to create an account, and we have the put methods to deposit and withdraw from an account. In here, we will auto-wire the account command service, and write the implementations of these methods. Response entity response created amount created it. Okay. Amount debited. Okay. Okay. Oops, this should be subtract. Okay. We could run this now to test the REST API under the command side, or we could just continue implementing the query side since we only have a few remaining things to do there. Let's just head over to the query side and write a service class to handle events that will be dispatched to us by the event store. Manage account service, annotated with @service. we want to auto-wire the account repository to be able to fetch and save accounts. First is we want to handle the account created event. Let's annotate this first with @slf4j for logging. And let's create a new instance of the account entity. Set balance, get balance. Created. And let's save that event. Let's also annotate this method with @event_handler to let Axon know that this method should be executed to handle the account created event. Next is we're going to implement the handler for account activated event on account activated event. Handling account activated event. We're going to search for the account we want to update. Or else no. If it exists, let's update its status, which is presumably in an activated status. Sorry. Get status count, and let's save it. This is the handler for an account credited event, also annotated with @event_handler. It's not null. Let's set the balance to let's just add up the amount to the current balance. And this is the handler for an account debited event. Account debited, which is basically the same as the event handler for the account credited event, except that we have to subtract the amount to its current balance. Now that we've got the code for the event handlers in the query side, what's left for us to do is to handle requests which we will receive through the REST API that we will open for getting the account details. If you can still recall, a query, in contrast to a command, is an intent to request for information or an object state. Let's write the method that returns an account and takes in a find account by ID query. Handle find account by ID query. Let's search for an account with the given account ID. And just return it. Let's annotate this method with @query_handler to let Axon know that this is the handler for find account by ID queries. Let's open our Manage Account Controller. Let's auto-wire Query Gateway as a dependency, which is also like the command gateway for commands, an API that lets us submit queries. To implement the getAccount method, we will call the query method to send an instance of findAccount by ID query containing the account ID from the query string. If we find something, let's return. If we didn't find something, let's return a 404 not found status. Else, let's return that account with an OK status. OK. Finally, let's run our code with mvn clean spring-boot :run. And now that it's running, let's head over to Postman. Let's hit our REST endpoint to create a bank account. Call it 8080 / bank create. It's a post. Starting balance. Let's give it a starting balance of 10 grand. And let's hit send. And as you can see, this is the account we created and is already activated. To verify that, let's query for that account with this account ID. Let's change this account ID here. And as you can see, here is the account we created with an initial balance of 10K and the status of activated. Now, if we go back to our IDE and see the console logs here, which, as you recall, we added some logging earlier in our code. This is the point where our app received the command to create an account. That command was handled and an account created event occurred, and that event was handled and an account activated event occurred. And also, as shown by these logs, you know that we were able to handle those events, including the query to get an account ID. Now, more importantly, let's see how our account was saved in our HUDB. Let's log in. Of course, the most recent state of our account was saved in the account table from the query side. This is how we handled an account created event dispatched over to the query side from the event store, if you still recall. Finally, let's head over to our domain event entry table, which was created to us by the Axon framework, and this is where event sourcing kicks in, and you will see that our event store saved all the events that occurred when we created an account. You will see here a global index and a unique event identifier, the metadata, which I assume is in some kind of hash, I'm not sure. And we also have a payload here, which I also assume in some kind of hash. But the more interesting fields that you will see in here is the payload type, which holds the events or classes of events that have transpired. You will see that we created an account and that we activated that account we just created. We also have the timestamp here, which is the date and time of the occurrence of the event, and the aggregate identifier, which uniquely identifies the instance of the account aggregate where these events belong to. And as you can see, these events have identical aggregate ID because they happened on the same instance of the account aggregate, which is referring to the account that we just created. Let's go to Postman again, and let's try to deposit to our account. Should be put localhost 8080 bank account deposit. JSON. Account ID should be the one we just created. Oops, I have to get it here. And the amount, I'm gonna deposit $1,200. So for that, and let's hit send. And as you can see, it says the amount was credited, and let's see if that amount was really credited. Let's hit this endpoint again. And as you can see, $1,200 was credited to our account. So now I am also going to try to debit or to withdraw from that account. Let's say body raw JSON. Let's copy this same request body with the same account ID, but this time let's try to withdraw $700. Localhost 8080 / bank account withdraw. Okay, as you can see, it says here amount debited. Let's see if that was really debited. Let's try to hit this endpoint again, and as you can see, $700 was deducted from our balance. Now let's go back to our domain event entry table, and if we run this again, as you can see, we now have 4 events here, and the new events are the account credit event from when we deposited to our account, and the account debited event from when we withdraw from our account. You will see that all 4 all four of these events have the same aggregate ID, which is practically just the account ID, because they are all referring to the same instance of an aggregate. And we also have a sequence number here. The sequence numbers here, which is the exact order in which these events have transpired. So that's it for this tutorial. I hope you guys liked it. If you have any questions, feel free to write them in the comment section and I'll do my best to answer them. Don't forget to hit like and subscribe, and thanks for watching. Bye.